Hello everyone. Welcome to the demo of Ask Confluence app. There is one script to pull data from Confluence and two APIs, one to add data to a vector database and another to fetch query results from it. This script pulls data from the Confluence connector. This API saves the extracted data to a vector database in batches. The batch size and load batch parameters in the query enable efficient batch loading into the vector database. This API retrieves results from documents based on the question parameter provided in the query string. The Confluence connector requires additional details to retrieve data from Confluence. Base URL, access token, space key, username. These details can be configured as environment variables, which the application utilizes. Now, let's jump in understanding the data flow of this app. The Confluence connector pulls all pages and saves them as raw text files. The API then saves this data into the vector database in batches, processed one at a time. When a user submits a query to the query processing unit, the system connects with the vector database, commonly referred to as VectorDB, to retrieve relevant results as context. This context, combined with the user's query, is then forwarded to the large language model, or LLM, which generates a tailored response based on the provided information. Let's take a look at how the files are stored after pulling data from Confluence. As you can see, there's a long list of text files that have been pulled using the Confluence connector, powered by LangChain.js. Now, let's take a look at where the vector files are being stored locally for this demo. These files are saved in batches using the API. We can adjust the parameter values when calling the API, which will directly affect the database chunks or shards count. As you can see, there are 19 chunks for the vector databases. These chunks were created to optimize performance and efficiently manage the database. Now, shifting from the Vector API, let's see the app in action. Using the RAG Output API, it retrieves results by searching through the vector database we've built. What we'll do next is hit the API with a question that might exist in one of the documents stored in the vector database. As you can see, the API returns the results in JSON format, with a set of 5 results. These results are retrieved from the 19 vector store chunks and are prioritized to display the top 5 based on their scores. These results will serve as context, paired with a query, and passed to the LLM. The LLM will analyze the context and generate the final output. This output will eventually be displayed on the front-end app. Now, let's take a look at the front-end app in action. This is where we'll input our query, pass it to the LLM, and view the result. Let's go ahead and enter the same query we used earlier in the vector search to see how it performs this time. As you can see, the output is now more user-friendly. While it still requires some refinement, it's definitely an improvement over the previous format. Let's switch things up and try a different question, something that might be stored in our vector database. Let's see what we discover. And there we have it. We've successfully retrieved some details related to the query we asked. And here's the vector search output for the same query, showing the top 5 results retrieved from the entire vector store. Let's now test a negative scenario to verify that the LLM doesn't generate outputs beyond the scope of our provided documents. As you can see, the LLM correctly limits its results to the boundaries of the provided documents, ensuring it doesn't generate outputs beyond the given context. And that wraps it up. Thanks for sticking through the demo.